Okay, we are officially live. Now, what we're going to work on today is called solving rational equations. So up to this point now, I know actually there's going to be a little teeny bit of review for the conceptual group, right? Because I think Nate taught this last time, but it's not going to be very much of the lecture. The more bulk of the lecture will be something that's new to all of you guys. Up to this point, when we've been dealing with rational problems, they've always been expressions, okay? We've been simplifying rational expressions. I give you an expression, a fraction, and you have to factor the numerator, factor the denominator, and then cross out similarities upstairs and downstairs, and then write it in simplest form and tell me the excluded value, right? Remember all that, right? And then we talked about multiplying them. Same idea. You have to do the same thing as you do when you're simplifying. And then we talked about adding. Adding is a little different, right? You guys have noticed the difference with adding and subtracting? That you still have to simplify, you have to factor the denominator, but you don't factor the numerator. You factor only the denominator. This is where this is totally different than the others, right? You factor only the denominator and make sure you have common denominators. Then you you add all of the numerators together. You have to actually distribute. If there's parentheses, you've got to get rid of the parentheses. Add like terms, and then try to factor that, right? You're factoring that after you've added or subtracted the two expressions. Now, today we're going to talk about what happens when you put an equal sign in there, all right? Now, some of this you've been doing for years. Ratios, right? Ratios. So like if you had, 2 is to 7 as 8 is to x. You guys all remember these, right? So remember how when you have a ratio equaling a ratio, what is that called? Yeah, say it again. Proportion. Somebody's saying it. Yes, proportion. Who said that? Oh, thank you. Great, exactly, proportion. So how do you solve it, Kareem? Cross multiply. You guys remember this? Everybody should remember this. Cross multiply means this. That times that equals that times that. So you've got 2x equals 7 times 8, which is 56, right? And then divide by 2, and you've got, what did I do?
28.
Oh, 28. Oh, sorry. I thought you were saying I did something wrong. Sorry. X equals 28. So they're really easy. If it's a fraction equaling a fraction, it's a proportion, right? Piece of cake, right? Everybody, fist of 5, piece of cake, right? You remember this enough? I'm sure you've experienced it somewhere. Yeah. All right. So this first section of the lecture is using this principle only on slightly harder problems. Okay. So we're going to try one and see how that works. So our first example number 1, is going to be 6 over x plus 4. 6 over x plus 4 equals x over 2. Okay, so that's really easy, really. But same idea. We have to multiply this times that equals this times this. I like my x's on the left side personally, so I'm going to do this one first. It makes no difference which diagonal you put first, right? No difference at all. So I'm going to do this, but I'm going to write it out like this. X parenthesis x plus 4 parenthesis, right, equals 2 times 6, which is 12. Okay? So now we got to think of it. We've got an equal sign. Up to this point, we've not had an equal sign, so all we've been doing is simplifying, right? But as soon as you put an equal sign in there, you're expected to solve for something. What do you suspect we're solving for? X, right? I mean, that's the unknown, is the x. So we're going to solve for that. I can't solve for that the way this is. I have to multiply things out and combine things. It has to equal 0. Now, if that equals 0 right now, I wouldn't have to multiply it out, because then I know if a times b equals 0, then either x equals 0 or x plus 4 equals 0. But it doesn't equal 0. It's 12. That totally screws up my plan, right? I can't do that. So I've got to multiply it out. Get rid of these parentheses. Get that 12 over into it, right? So that it equals 0. Remember? Because this is going to be a quadratic equation, basically, right? So x times x is x squared. Plus 4x is equal to 12. I don't want the 12 over there. I want it to equal 0. You guys all remember that? Minus 12. You taking notes, Liam? Or? Okay, good. All right. So we got x squared plus 4x minus 12 is equal to 0. Okay, sorry. I know I'm in your way. Get your notes out.
Can we complete the square?
Notes. Okay?
Can we complete the square?
So now,
Back to point.
well, you could do that, but maybe we could factor first, right? It's just a quadratic trinomial. Let's just try. Let's see. Factors of 12. Negative 12 that add to 4. How about 2 and 6?
And negative 2.
So positive 6, negative 2, right? So x, what did I say? Plus 6 times x minus 2 equals 0. Therefore, my answer is either A. If A times B equals 0, then either x plus 6 equals 0, which means x is equal to negative 6, or x minus 2 equals 0, which means x is equal to positive 2. Okay, and that would be my answer. So I have two answers. Does that make sense? So your same thing, it's just a ratio, it's a proportion, right? Two ratios equaling each other. You cross multiply, and then if it becomes a quadratic, you've got to, you've got to factor. You've got to multiply it out and then make it equal to 0 and then factor and give me the final answer. Okay? Just a 5? Sorry. Just a 5. Good. Well, okay. Let me see everybody's. I just want to know where people are at. Okay, so nobody's totally lost, right? Okay, so that is the easy stuff. Now we're going to look at the harder stuff. Okay, I'm just going to give people a chance to finish this. I taught you a trick last year, and I told you whenever you have an equation that has a fraction in it, I told you to do something. Do you guys remember that trick? Because I told you also that I tell everybody this trick and everybody forgets it because they don't think it's that important. It is so important, and you're going to use that trick today. All right, so can I erase this now?
No.
All right, so I'm going to do my other trick here. I'm going to show my other trick here. So this is just sort of a prelude into the next part of the lecture, okay? If I gave you an equation like this, 1/3 x plus 2/3 equals 8/3.
Multiplied by 3. Both sides by 3.
Right, because you look at your denominator of each fraction, right? Happens to be the same denominator in this case, right? So if I multiplied everything by 3, I would be doing that. I would be doing this, whatever I do to one side, I do to the other, right? I could multiply this times 3 and this times 3. That would be multiplying the left side, and then I could be multiplying this times 3. So what happens when I do that? Let me put a plus sign here, and I'm going to put 3 over 1, 3 over 1, and 3 over 1. Right? And then those 3's cross out. So suddenly you have your numerator left. You don't have any denominator, you just have the numerator. So 1x. So 1x is just x plus, look, the 3's cross out, I have my numerator again. 2 plus 2 equals, the 3's cross out, I have my numerator again, equals 8. So I could have even done that in my head. I could have just said, okay, multiply everything times 3, get rid of the denominator, it's just x plus 2 equals 8. Right? Subtract 2, x is equal to 6. That was so easy. Right? Yep. You're all with me, right? Remember this rule? Remember this trick I taught you?
Gary, what if the denominator's different?
Okay, perfect question. That's perfect. Okay. So we'll do another one where the denominator is different. So let's say we have 1/3 x plus 2, well, let's say 3/4. Doesn't really matter what it is. 3/4 equals 10. Okay. What would be, if I were going to add these, I would have to have common denominators, am I right? What would be my lowest common denominator? 12. So instead of multiplying times 3 and then multiplying times 4, let's multiply everything times 12. Okay, watch this.
Oh yeah.
If you multiply that times 12, this times 12, and this times 12, whoops. This is on the computer. Yeah, okay. So then look, 3 goes into 3. Now this is not, it's going to change the numerator a little bit because this is not the same number, right?
Yeah.
So suddenly 3 goes into 3 once, 3 goes into 12 4 times. 4 goes into 4 once, 4 goes into 12 3 times. And then that's that. Okay, so we have 4 times 1x. So we have 4x. No denominators though. Look, the denominators are gone. 3 times 3, so plus 9, equals 120. And then I just solve it, right? Piece of cake now. This is so much easier to solve than that. You see what I'm doing? It's easy. So all I did was I multiplied everything by the lowest common denominator. And I completely eliminated all fractions. Like, the only time this works though is when it's an equal sign, when there is an equation. It does not work with an expression because you can't multiply both sides, right? You know what I mean? You're violating that rule. If there's not two sides, you can't just randomly choose a number to multiply by. You've changed the equation. You've changed the fraction then. But if you have an equation, you've changed them proportionally so that you'll still get the same answer. Okay? You get what I mean? So now we're going to use this concept to solve complex rational expressions, okay? Rational equations, sorry. It's really amazing to me, you know, once people get these ideas, you know, and they go with it, it's like really cool. I just think it's pretty cool. So let's say I had this one. I'm going to write this one out so I don't forget. So we got, this is example 2, right? So let's say we have this. We have x. I'm going to leave myself a little space here because I know I'm going to probably need it. X over x minus 2 plus 1/5 equals 2 over x minus 2. So I notice that I have 3 fractions. 2 of them have the same denominator. Just make sure I did write that right. Yes. 2 of them have the same denominator, but one of them doesn't. So what is my lowest common denominator? Clayton.
5x minus 10.
Yeah, but keep it in factor form. So
X minus 2.
5 times x minus 2. Would you agree with me?
Yeah.
This times that, I could make all of these be 5 times x minus 2, right? I could do that. So let's do that. So, right, you see how this one's missing a what in the denominator? A 5, right? So I'm going to multiply this one times 5 over 5. Okay? What's this one missing? An x plus x minus 2, right? So I'm going to multiply this by x minus 2 over x minus 2. What's this missing? A 5, so I'm going to do 5 over 5. So suddenly I've now got to multiply out my numerator, but my denominator, I'm going to just put it down right now. It's 5 times x minus 2. It's always good to keep this in factored form, the denominator. Don't ever do it 5x minus 10, because eventually we're hoping that we'll be able to cross out the x minus 2 up here, right? That's our goal. It may not happen, but that's our goal. So now I'm going to put all of this numerator stuff above here on this side, and then we're going to have an equal sign, and we'll do the same thing there, right? So actually, what am I saying? What am I doing? Sorry. Sorry, I screwed up. I was thinking expressions, not equations. But by doing this, no, wait, what am I doing? Sorry, I'm starting over. Yes, I'm starting over. I'm starting over. I'm thinking rational expressions. I gotta change my. All right, we're starting over. Sorry, I screwed up.
Wait, shouldn't we restart the video then?
Okay. Wait a minute. Okay,
Yeah, you
give me.
should restart the video.
I forgot the problem.
we don't.
X over X.
X
That was
over x
amazing.
minus 2 plus 1/5 is equal to 2 over x minus 2.
So should we erase everything?
2 over X minus 2. I screwed up. Sorry, I wasn't thinking. I was thinking something different, right? I was thinking multiplying rational expressions. I wasn't thinking solving them. So what I want to do is I want to multiply every term by the lowest common denominator. Like right here, I multiplied everything times 12, right? I took 3 times 4 is 12. I multiplied everything times 12. So I've got to multiply everything by 5 times x minus 2. Does that make sense? It's the same thing I did there. So I'm going to smooth that too. Get over here. So we've got, I'm going to multiply everything. So this is going to be, I'm multiplying it times 5, not over 5, not, okay, 5x minus 2, all over 1. And I'm multiplying this by 5x minus 2, all over 1. And then I'm multiplying this by 5x minus 2, all over 1. Just like I multiplied this by 12 over 1. Right? So this has the lowest common denominator. I decided that my lowest common denominator was 5x minus 2. 5x minus 2. So I'm multiplying everything by 5x minus 2. Has everybody written that down? Because I want you to see the next step.
But Gary, should
All right, so watch this. So this is where you cross things out. I can cross upstairs, downstairs. It's these two fractions. I can cross out the x minus 2, the x minus 2. Right? Suddenly, I have no denominator here. I just got rid of my denominator. So all I have left is 5 times x, which is 5x. Right? You with me?
Yeah.
Does that make sense? Tess, you writing this down? You writing this down? Do you have notes? Because you're not, I mean, you got to know this. I mean, you got to have it in your notes. So 5 times x, and then plus, now same thing. This time though, the 5 crosses out, right? The 5s cross out. I now no longer have a denominator, right? No denominator. So I have x minus 2 times 1, which is just x minus 2. Okay? Equals, over here, I have x minus 2 and x minus 2. I can cross those out. Look at that. Now I have no denominator, because that's just 1. 1 times 1 is 1. I don't need a denominator of 1. So 2 times 5, which is 10. Suddenly that horrendously looking horrible equation becomes so simple. 5x plus x is 6x minus 2 is equal to 10. Add 2. We have 6x is equal to 12. Divide by 6, x is equal to 2. Right? Look at that. So easy. It's just a little complicated because it's so long. You have to write everything out. But once you do it, it's so simple because the things cross out. So you will immediately, by doing this, immediately completely eliminate all fractions in your equation. Okay? Does that make sense?
Wait.
Okay, question. Yeah.
Just as a little question here. Would this equation be undefined if you plugged your answer back in?
Because it's 2 minus 2
Huh.
is 0.
Oh, that's intriguing.
Oh no.
That's a very interesting question.
0 over 1 times 0 over 0.
That's intriguing.
Yeah, you're right.
Oh,
You're right.
What?
So they call that
Being undefined.
this is actually called an extraneous solution because, thank you for saying that. So you've got to go back and look at this and make sure that doesn't make anything. That's one of the reasons you have to know the excluded value issue. You know what I mean? What is the excluded value? In this case, the excluded value is 2, and that's what we got. Therefore, the answer is no solution because that's the only possible answer, but it's not possible because it makes this impossible, right, to solve. Because the actual answer is no solution. Gosh, I never even thought of that.
how did the
Thank you so much, Nathan.
Excuse me,
That's
Gary.
good.
This is a great video. Boy, I'm loving this video.
Gary,
What? Yes.
how did the 6x turn in? How did the 5x
5x plus 1x is 6x's,
Oh, yeah.
right? Minus 2 equals 10. So, and you all understand that because 2 minus 2 would be 0, and that would be in the denominator, that is not only the answer, but it's the excluded value. Therefore, there's no solution, right?
For the fabulous math. What? I don't
All right,
really
awesome. So good. So that's number 2. Now let's do the third one. Let's hope the third one doesn't do the same thing to me.
Just be super, super careful about
It would be. It would be.
Erase today.
Can I erase all
Not just
this?
quote of the. Good job, Gary.
Quote
All right.
of the.
Quote of the.
Is that a?
All right.
Quote of the.
If you're gonna erase it all the way.
This is
We did.
we
Okay.
need a quote of the.
So this is now example number 3.
Quote of the.
And let's see.
Gary, write it like a few inches past the number. Just so you
Okay, so here we go. We've got 3. What time is it? Okay, we're fine. 3 over, where am I? X minus 7, right? Yeah. Plus 1 equals 8 over x squared. So you guys, you should be writing this down.
Gary, she's asked for
She just asked for 5 more minutes.
Oh, great,
like till 9:15.
great. Doesn't this end at like 9:10?
Yeah. Yeah.
Okay, great. That's awesome. So, minus 9x plus 14. Okay. So, let's just remember what we're doing. The first step is to find a common denominator, right? We need to know what that would be because we're going to multiply everything by that common denominator. Now, that's easy to look at. This doesn't even have a denominator. This is like 1, a denominator of 1 basically, right? 1 over 1. But this, in order to do this, what would I have to do with this? I'd have to factor it because hopefully one of the factors is x minus 7. It might not be, but it might be.
-7 and -2.
So, all right. So I'm going to just do it right under here. So we've got x and x. We've got minus 7 minus 2. That works. Minus 7 minus 2. Right? So with that,
So you want us to factor out the denominator.
what is my common denominator? What would it be if I were going to create common denominator?
X plus minus 2.
X
say it
minus 7
again.
times X minus 2.
X minus 7 times x minus 2. That would encompass everything here. It would encompass everything here. Right? There's, and it would work, right? There's no additional stuff. There's not an x plus 7 or x plus 13 here, right? I don't have to add that in. It's just an x minus 7. This encompasses this, encompasses this, and this just has a 1 and there's a hidden 1 there, so that's fine. So we're going to multiply everything by x minus 7 times x minus 2. Then I'm going to just rewrite it here. So we're going to do
X plus 2, by the way.
minus 2.
Oh, yeah, because it's 9.
So we got x minus 7 times x minus 2. All right, times, how do I write this? Times 3 over x minus 7. If you want to put this over 1, you can, if that makes it easier for you. Plus, now 1 times x minus 7 times x minus 2, right? You with me? I'm just multiplying this times this. Now the 1 times this equals, now I have 8 times this, x minus 7, x minus 2. Okay, you with me? Everybody see what I did? Now, I have, oh wait, I didn't write these. Sorry, that's what I didn't forget. Sorry.
Wait, what?
Sorry, I screwed up.
No.
No, it's okay. You can do that. We'll just put this here because that's going to go in the numerator anyway, right? When you multiply it, it'll just go in the numerator. And then in the denominator, we're going to have x minus 7 times x minus 2, right? You with me? So here's the fraction, and then I'm multiplying times this. Here's the 1, I'm multiplying times this. Here's the fraction, and the 8 was moved over a little bit, and I'm multiplying it times the x minus 7, x minus 2. But when you're multiplying it, it's part of the numerator anyway, right? Did I lose you guys on that step?
Yes.
just a minute ago.
You guys told me not to erase it, but I'm going to erase it so you can see.
What?
So here's my fraction, right? X minus 7, x minus 2. Yes? That is here, right? You with me? This is the same thing as this, right? But I have to multiply everything by this, right? I've multiplied this fraction by this. I've multiplied this 1 by this. Now I've got to multiply this fraction by this as well. So I've got to do times x minus 7, x minus 2 all over 1, right? You with me now? Does that make sense? More sense to you? Okay, so now we cross things out, right? So we've got x minus 7, that crosses out. So we have no denominator now, right? It's just denominator of 1, so we don't need it. So it's just 3 times x. I'm going to use the distributive property here. So I have 3x.
Well, I thought you said not to do that.
Minus 6. Upstairs you want to. Upstairs you want to. All right? Now, plus, I have no denominator anyway here. So I have this thing. I've got to get rid of the parentheses. So what would I use to do that? What process? FOIL. So x times first is x times x. That's x squared. Outside is negative 2x. Inside is negative
Isn't it
7x,
just,
negative 9x. It's actually this, isn't it?
Yeah.
Plus 14. All right, equals. Now I have x minus 7 crosses out, and my x minus 2 crosses out, so it just equals 8. Look at that. That's awesome. So now all we have to do is combine like terms and write it in proper order. Proper order is what? If there's an x squared, you would write that first. If there's then just a plain old x, you'd write that second. And if there's just a plain old number without an x, you write that third. Just like a typical quadratic expression, right? So I can see there's only one x squared. I'm going to put that first, x squared. Now there is positive 3x minus 9x. So that would be, if I combine that, that would be minus 6x. And then I see that there's a negative 6 and a positive 14. So what's that, 8 plus 8 equals 8. All right, so now what would I do?
Subtract 8.
Which 8?
After the equal sign.
I want to cross that.
I want to subtract this one, right? I guess it doesn't matter because they're both going to do the same thing,
Yeah, but
right? But the idea is I want it to equal 0, right? That's my goal before I try factoring. I want it to equal 0. If you don't forget, if you don't remember anything else in my class, remember that. Quadratics, always set it equal to 0. Because then you can solve
All right,
it
Garrett,
really
I'm
easily.
taking with me in high school.
So we've got x squared
Yeah.
minus
Forget
6x.
Everything.
Forget everything
Just
except
forget
this.
I'll just remember this. That's all I'm gonna remember.
That's all you need to remember. That's everything.
That's it. I'm
What's
done
the
with math
one
class.
thing you
See you guys.
forget out of all
That
this
and
stuff?
friends never let friends
Right.
divide by 0. Dee
Yeah.
was in study hall yesterday and she said, Gary, I'm going to divide by 0. And I ran up, she gave me that shirt that said friends never let friends divide by 0, right? And I ran up to her and I shook her and I said, no, you can't do that. I won't let you. Never.
You're on
So-
video.
Oh yeah. Okay, so we have x squared minus 6x equals 0. So what do I do now?
Where?
Yeah, you shadow.
Yes.
What?
Move the x over to the other
Oh, you
side.
just factor, right?
Add 6x.
Factor, right. What's the first thing you always try when you factor?
Oh, wait. What did you just
Greatest common factor. That's the second thing you have to remember.
Okay.
So x times x minus 6 equals 0. So now if a times b equals 0, then either x is equal to 0 or
X is equal to 6.
x is equal to 6.
Yay.
Right? So that's how you solve it. Now let's go back using what we learned last time from Nathan. Thank you, Nathan. What? Wake up for just a second, okay? What we learned last time from Nathan is we also want to just check these and make sure we don't have anything that's illegal, right? And we have x minus 7. Neither of these would screw that up. And then we have this. Neither of those would screw that up. So those are our answers. X is equal to 0 or x is equal to 6, okay?
Can you, wait,
and-
Gary, is
yeah.
homework in the book?
The homework is out of the book today. Yeah. So So let's just remember, let's just do a quick review of what we did, okay? Quick review of what we did. We have an equation that has fractions and potentially no fractions, right? We have to have a common denominator in order, we have to figure out what the common denominator would be. In order to do that, we have to factor anything that's not factored, right? And then we look at it, like there's x minus 7, x minus 2. This one has the x minus 7, but it's missing the x minus 2, so that would work. And then this one doesn't have any denominator, so it doesn't matter what you multiply it by. So we multiplied everything by the lowest common denominator, which is x minus 7, x minus 2. So this times this, the 1 times this, equals the 8 over this, only I wrote it in factored form, times that. And all that stuff crossed out, and I had just one line then, right? Okay? And then I wrote it in proper order, combining like terms, set it equal to 0, and solved it. Really pretty easy, okay? So,
Can you give us time to work on our homework?
so that is that. Let me just look. Let me just look and see.
9 minutes.
Give me an idea. Just to 5. How are you feeling about this? Do you want me to do another, or do you want me to just give you the homework? And okay, let's vote on this. Do you want me to do another one, or do you want me to give you the homework and you work on it? So those in favor of, raise your hands, everybody, raise your hands. Those in favor of me doing another one. Okay, looks like it's unanimous.
Wait, what? Gary, no.
Those in favor of me
hands
giving
down.
homework? I'm.
Those in favor of giving homework?
Wait, actually, no, don't give homework.
I've never had a class that wanted to do homework. I mean, this is amazing. You guys are amazing. Like, I wasn't even going to give it, but because you've, like, given me this, like,
What?
I'm just pumped. I'm sorry. That's okay.
No.